Well, welcome to class. It's nice to meet y'all. It's a little weird having lab first, sorry. But we'll make do, and I think that'll be fine. So labs will be on the stuff we covered the week before, and then we'll start new stuff Tuesday and Thursday. That'll be the general flow. Yes, we hike out to Castle from HPEC 1190. Not too bad. This is me. Hi, I'm Eric Janeski. I don't think I introduced myself before, sorry. If you want to email me, please use your email, not the Canvas mail feature, because it goes to the other inbox because it filters out and thinks Canvas spam emails me too much, and I won't see it right away. So just use regular email. Feel free to call or text me. This is my cell phone number. I think I have an office phone here somewhere. I've not used it since I started in 2016 because that's a lot of extra work to have another phone number and like voicemail to check, and it's just silly. I do have a shared office space, but no one's ever there, so it's basically my office space. In CIS 237. That's the building you've probably never been in because there's no classrooms there. There's a lab downstairs with a bunch of computers that no one ever touches because everyone has laptops nowadays. And then all the CIS offices are in there as well. So I hang out there between classes Tuesday. So I've got 11 to 11:50 or so, and then from 5 to 5:50 before my class at 6, I'll be over there. And then Thursdays between classes, 11 to 1:50 because we don't have our lab on Thursday. So we just up until I walk over here for 2 on Thursday. So feel free to come on by. If you don't see me, call or text me. I'm probably just getting my coffee from somewhere. But essentially I sit around and work and grade stuff, and then you can drop in and say hi, ask questions, just talk about random technology things. I'm not very good at answering people-y kind of questions. I like computers for a reason. They're much easier to understand than people. Go talk to the social science folks if you got people questions. But that's here. I'm happy to help. And then I can meet by appointment lots of other times. My schedule's pretty flexible. Zoom is super easy to do screen shares. So don't feel like it has to wait to ask me a question for Tuesday. Ask me anytime. If I can't help you right away, I won't help you right away. But pretty much get back to you pretty quick. Like any good millennial, I'm addicted to my phone. It's always with me, unless my son's watching YouTube Kids on it because he has a Kindle, but it's not good enough because Dad's phone is much cooler, apparently. That's why the screen's all sad. But yeah, so reach out anytime. I'm usually up really late. I think you saw my announcement 2, 3 this morning, whatever it was here. I don't like mornings. So not usually doing much in the mornings. And after being on call for 12 years straight, 24 hours a day, my phone is now basically permanently on silent because I can. And it still feels really fun. I spent almost 20 years in industry before I, quote, retired out of industry to teach full time because teaching doesn't pay the same. But that's why I teach here and at OCC and at Walsh. But it's a lot of fun. Teaching's been great. Been doing that since 2012. Been here since 2016 when we started the data science program. They brought me in to teach these Python courses. I was yeah, I like Python. We did a lot of Python at work. Worked for a healthcare analytics company, did a bunch of data analytics stuff. I never called myself a data science person because I don't know the medical side of things. So I can set up all the pipelines, I can crunch data. I don't really know what it means if your labs are out of whack. The domain expertise is not something I had in healthcare. So I could do all the tech stuff. Did a lot of fun things. Love data, love numbers and math and stats and sorts of things. So amazing things we can do with technology that are just super cool. And I like to ramble and tell a lot of stories about silly things here. But lots of fun things we can do. This was hopefully a copy paste from the catalog if I did it right. Here's the link to your program learning goals. These are things you should do when you finish the program. Most people don't ever click these links or care about these things, but it's part of our assessment process that the Higher Learning Commission looks at to make sure we're doing higher education things. Here, specific course objectives. This is a long list of things that might not make any sense because we haven't talked about them yet. So don't worry about it. We'll come back to it here. So 2 options for the textbook. We were using the physical copy of this Data Structures and Algorithms in Python by Goodrich, but it's $140 new despite being 10 years old. I don't know why, because publishers like to make a lot of money. So sometimes you can get used copies. The bookstore wasn't great about that. So I found the Zybooks company, which is actually also Wiley because they bought Zybooks, started publishing regular books as Zybooks. So there's no fun interactive stuff. There's a couple graphics every now and then, but it's essentially just a website book. But it was $68 for a subscription to it. So you just have to go and print every chapter as PDF to keep it. But $68 was better than $150. So either one, perfectly fine. If you Google hard enough, you'll find the PDF. I still feel bad about that because the author himself put a lot of work into it. I don't really care about the publishing company because they all suck and they try and take all the money they can. But at least Goodrich hopefully gets something out of it here. So I don't recommend piracy, but you've got options, right? I'll leave that up to you. We use GitHub. I'm a big fan of GitHub because it was made for code. It really irritates me when people email me code because it sucks. Then you have to download it and I have to open it up on this and I can't do it on my phone and all sorts of things. But with GitHub, you just send me the link and I can see it from my phone. And at this level, probably about 75% of the time, I can just look at it from my phone and tell you what went wrong here. I don't actually need to put it on my laptop and run it and do any of that stuff here. So GitHub's fantastic. I'll use that for all the code I do in class. I'll put out to the course repository that I created in lab, and that way you can go view it. I don't upload things to Canvas because it sucks putting code in Canvas, right? When you have other classes with other profs and they tell you to put code in Canvas, they put their code in Canvas. Don't tell them they're stupid, right? That's just a bad idea. No one likes to hear that, even if it's true. So just don't. And I use PyCharm for everything. You're welcome to use whatever IDE you like to develop Python. I like the bells and whistles in it, and it's nice and easy to use. The debugger's really nice. And the folks at, JetBrains have a lot of nice tools that they use. What everyone seems to care about for class, how you get your points, right? Because letter grades are apparently the most important thing in higher education. Sure, not the learning, but the letters. They're supposed to be related, but that's okay. We'll let the folks research that. So labs are 15% of your grade. So the lab scores are typically 10 points per lab. All of those together make up 15%, right? It's a weighted system here. I've got quizzes that we're going to do for 10% of your grade. Individual projects make up 25% of your grade. We have one exam, just a midterm. It's open book, open notes, open internet, not open neighbor. This is going to be your individual effort. I'll give you last year's midterm to practice on. There'll be similar questions on the same topic, same sort of thing. It's not meant to be a surprise. This is just a quick check-in. If you do well on it, good, things are good. If you do bad on it, then we've got to have a conversation because it was supposed to be easy. I'll be honest, it's not meant to be hard. It's just a checkpoint here. And they look at me funny if I don't have any tests on my syllabus. And then the final project, this is the bulk of your scores, 40% of your score. This one is a group project. Ideally pairs. There's just not really that much work to do with 3-4 people. So pairs is generally preferred. Maybe a trio if we've got an odd number here. But we'll do that. That's 40% of your score. So you do not pass the class without this final project. That's the goal. All the things we do in class build up to this final project, and we do something slightly more interesting than last time here. Do something, again, not exactly data science-y, because we just don't have that scale yet. We don't have all the tools yet. I like doing things with simulations and running experiments and looking at numbers and tweaking results. Sort of not machine learning, but kind of stepping towards what does that look like now if I can automate this sort of process. So we're going to kind of do those steps by hand. I want to run a bunch of things, experiment, see my results, tweak some stuff, run a bunch of things, see the results, tweak some stuff. This is sort of what we would now further automate to get actual machine learning happening, but we're going to do it by hand, right? Just to sort of learn how that works, right? I think engineers put cars together to learn how they work rather than just starting with a whole car. So that's sort of fun. The plan for the semester, right? I only have the lecture topics here. The labs, again, are going to be from the week before. So we do have an extra lab on Unix that I will spend 2 minutes talking about because I find it terribly dull. But it's really interesting, fun stuff. So we can run Python on another operating system that is not Mac and is not Windows. So we'll do it on the college Unix server. We'll do that next time. So I'll show you how it works on Thursday. And then on the following Tuesday, once you've forgotten everything I did, we'll go and try it ourselves. The timing's a little awkward, but it's okay. So we'll go and run Python on the college server, which is kind of fun because you can make the college server do a bunch of work for you that your tiny little laptop might not be able to crunch. So it's really handy, and that sort of thing is common. We don't do all the number crunching on our laptops when we've got billions of pieces of data. Right? We do that on servers elsewhere. So that sort of idea how we remotely connect to things and run processes, it's good practice. It's just really obnoxious to do it in Unix. But part of our accreditation process, there's a checkbox that says we've taught students more than one operating system. So we do it in Unix. And it's fine. It's a good experience. And then you can get in on all the jokes about VI or Vim and how hard it is to exit once we've done that because it's ridiculous. But, okay. Anyway, you'll enjoy that next week, I promise. All sorts of fun coming up. And then we basically take a chapter a week. So we've got object-oriented programming. We're going talked about it a little bit. We wrote some classes, we did some testing. Last semester, we're going to go a little deeper here, do a whole project focused on writing classes, writing some tests, getting deeper into object-oriented programming. We'll do a whole week on recursion. We'll have a whole project on recursion. This is another topic where a function calls itself. Right. We, again, kind of scratch the surface. We'll go deeper on it here. We get into our array-based sequences. Now, these are lists in Python, but behind the scenes, there's lots of cool, fancy things that can happen to make these things very efficient. So one of the topics that we get into with CS2 is looking at how efficient things are. Right. The first semester is just like, get it to run. I don't care. I just want it to run. Now we find like, okay, it's running. Is it running fast? Is it running efficiently? And when we talk about efficiency, notice we skip chapter 3. It's terribly dull. I'll give you the highlights here on how we talk about efficiency and measure efficiency and all the sorts of symbols and numbers and nonsense here. But we care about how much space it uses in memory. So how much data are we storing on the computer while it's running? And we care about how fast is it running? How much processing power is it needing? So there's space complexity and there's time complexity for how fast things are or how slow things are. And that's more the science side of things. How do we optimize things? So again, we sort of get into the topic a little bit, and then another semester in 350, your data structures and algorithms analysis, you go real deep into that stuff. So we sort of tee it up into this class. You're looking at these things, and then we look at specialty data structures. So it's a fancy term for how do we hold data in memory when we work on it. When I'm storing data in a list, what does that look like? If I want to store data in a stack or a queue, or this is pronounced DEC apparently. I don't know why it's not DQ, but it's DEC. Sure, we just go with it here. So how do I store data? What does that look like internally? What is it good for? What is it bad for? All these things are different tools we're going to add to our toolkit that this could be used to solve a problem efficiently, or this is not the right tool for this job. Right? There's a joke that once you have a hammer, everything looks like a nail. Not everything's a nail. Right? So we've got all these different tools in our toolkit so that we can solve problems efficiently. Linked lists we'll spend a lot of time on. We'll have a whole project on linked lists. It's just another way to store information. Then we spend a little bit of time on trees. We don't go super deep on trees. That's sort of where you pick back up in the 350 class. So we'll start at a high level with trees. We got spring break. After spring break, we'll do the midterm review and midterm. We can do it before spring break if you want. I assumed after was better. So like, I don't know. I assumed it was better. I'm willing to move it if anyone so cares and wants to convince the class that it's better to do before that. I'm open to it. But we'll spend the Tuesday reviewing and then the Thursday taking the midterm. I don't like watching people take tests, and they're open book, open notes anyway. So my plan is to not come Thursday, which would be fun, or maybe just be in my office because I have other classes Thursday. I don't think I'd put the midterm the same day for all of them. That was dumb. I should have scheduled that wrong, or better. But sure, I don't need to watch you take a test. That's open book, open notes. And they're not timed. So start it, look at the questions, come back to it, sleep, realize at 2 a.m. when you're showering that, oh, that's the answer I needed. Right? Have your epiphany thoughts whenever you do. Occasionally, there's been an emergency where I had to do something very quickly at work. That's the rare case here. Most of the time, they're like, hey, solve this problem. And I go solve the problem. And if it takes me 5 hours, great. If it takes me 10 hours, great. If it takes me 3 weeks, there's probably an issue here. I'm going to get in trouble. But you get the work done eventually, right? And, all sorts of other sort of processes and things there. But you don't need to do it in an hour. That's just silly. Right? And you don't need to do it off the top of your head. That's also dumb. No one's ever asked me to code stuff without any resources. So I'm not going to do that to you. And again, we'll have practices. So we'll get into priority queues. We do a priority queue from scratch, which is kind of fun, looking at how these things work. It's a type of tree. So it's part of this tree idea that we're looking at. And then we spend a brief amount of time on maps, hash tables, and skip lists. Skip lists, I tell you, here's the section. You can go read it if you want. But we build our own map and hash table, which is fun. And other ways to store data. They're fast for certain things and slow for certain things here. We'll spend a little bit of time on search trees. Again, it's a specialty type of tree. You'll get really deep into search trees and balancing trees and doing all sorts of fun tree stuff in the course. And if I recall, you still use the same textbook for the first half. So if you do the iBook options because it's cheaper, make sure you print the PDFs so you have them for when you take 350. They start with that. And then usually Dr. Ortiz goes further and has other sources of material. I forget what he does. I talked to him about it in 2017. And that was the last conversation I had about the class, because I don't care. I don't teach it. That sounds really bad. I'm sorry. I do care. You only have so much time, energy, and effort to focus on things. So he gets really far into trees, and then we do some basic sorting and selection. Again, you'll get advanced sorting and selection sort of things later on. And then we have one of my favorite weeks. We talk about ethics. Didn't seem like it'd be my favorite topic, but this is really important that we talk about and acknowledge that there's ethical issues in software and data science, and we can do some really good things, and we can also do some really sketchy things. And you can do some really bad things if you want to do bad things, but oftentimes we land in that gray area of, this is kind of sketchy. I don't know if this is something I should be doing. Right, so we need to talk about ethics and have an ethical framework, and there's a code of ethics for software engineering. I don't think there's one for data science yet. Last time I Googled, I didn't find one. I haven't Googled in a year because we haven't had the class since last year. We can look and see, but having that is really cool. So we'll spend some time on ethics. We'll have a silly lab. There's the moral machine little simulator that you pretend you're a self-driving car and you say, I should kill these people or these people. And you get to decide who dies. And then you'd like to see, do I think... That sounds really bad. I'm sorry. It's just a thought exercise. And that one's a lot of fun. And then the very last week, I've got set aside for your final project work time. So you can work together, polish things up. Ideally, we're going to start that somewhere around week 12. So you've got about a month to work on it here with your partner. We'll have some time, right, because we're not going super deep into these topics. We'll have some time after lectures in lab to work on them together. I love when people get them done by the last week, so that on finals week, when they have final exams where people think you have to memorize a bunch of stuff and be able to answer questions within 3 hours to prove that you learned something, you can focus on that. Right? When we do our final exam slot, it's your turn to present your project. You're going to run it, answer some questions about the code, show us it does what it's supposed to do. We all have a good time because we all did the project together. Y'all did the project together. I didn't do it, or I haven't in a while, and get to show it off. So ideally, it's done by 4:16. That's fantastic. If not, that's okay. You've got till, this is my birthday. I'm sad I have to be here at 8 a.m. for my first class for a final slot. But sure. And then we start presentations at 3 p.m. There's not very many of us. We do it in pairs. So within an hour or so, we're done. And then we take off and say, have a great summer. We'll see you in the fall. And that is the rest of your winter semester. Now, you have no life up until April, I'm sure. Good luck. All right. For me, some specific course policies. I'm rather particular about academic integrity. And I'll make my case for it. I'm sorry you've heard this soapbox speech before if you've been in my class before. But when cheaters get degrees, it devalues the degree for everyone who actually worked hard. Because when you go and get hired, because people think, you've got a college degree, you probably know a thing or two, and then you can't do the work. They're like, Dearborn sucks. We're not going to hire Dearborn graduates because obviously they don't teach people anything. And that sucks for all of us. Right? And then they're not going to hire us. So by making sure cheaters don't get degrees, you're keeping the value of your degree higher. Right? If someone wants to just see how you solve the problem, tell them to get lost. They don't want to see. They want to copy off of it. Right? If you want to talk about your code in English, you are welcome to talk your ear off. Talk as much as you want in English. I love it. It's really lonely and boring to be a developer who never talks to people and doesn't have a team to work on. Right? But the whole point of taking the class and learning how to code in Python is to learn how to code in Python. So we're going to take those ideas you've talked about in English, collaborate all you want, and then it's up to you to translate that into code and get it running. Right? And really, that's a lot of the work that we do, especially when we work on a team and as junior developers or data scientists. You'll talk with the team about plans for things, and then it's up to you to go and implement it. Right? You've got big brain, smart people who've done it before who can help you design it and figure out what steps need to happen. But then you've got to go and do the work of actually writing the Python code. Right? So as much as you want to talk about it, work together, it's fantastic, but don't share code. Right? In English is fine. If you've gone to code, we've gone too far. If they want to see your code, tell them to get lost. And again, it's just not worth it. Because if two people turn in the same thing, I have to deal with it. I don't like doing extra paperwork. It is a lot of paperwork to fail someone for cheating, because I have to fill out this giant form and show them that you've agreed to the academic integrity policy, that I have an academic integrity policy, that here's the code you turn in, here's the code someone else turned in. I have to diff the code to show them what's different, what's the same, because the dean has no idea what code is. He's an engineer, which is fine. He's a very nice guy. He just doesn't understand code. So I have to say, it's the same. Point out where all the things are. It's a lot of work, and I hate it. So don't do it, right? The dean gets notified. The academic code of conduct committee gets notified. Since I've been teaching in 2012, I've had one time where the academic code of conduct committee said I couldn't fail the student. And it's not because they didn't cheat, but because I didn't tell them they couldn't cheat. I don't understand why. So this has been through like 3 revisions now to be very clear that you're not allowed to cheat. They're like, oh, you didn't tell them they couldn't. What do you mean? It's a college class. What do you mean you can't cheat? Like, that one pissed me off, and I'm still bitter. But I've only lost once. So just don't do it here. Did I tell you the story about my 8 students that failed? Okay, so you can ask one of your classmates here. I got paid money to fail people and teach them again. I thought it was funny. You guys don't think that's funny, but it was great for me. Anyway, don't cheat. You immediately fail the course. There is no 0. There is no try again. There is no give me a different thing. You just fail. Cheaters will not pass my class if I can help it. And not to say people haven't cheated and I haven't caught it, that, I'm failable too. But if I can catch you, you will fail, right? I don't go out of it. Doesn't give me joy to fail people. I don't enjoy doing it. It's a lot of paperwork. But I do like to make sure that cheaters don't get degrees. That part is fulfilling, right? In that term, the Maslow's pyramid of self-fulfillment or whatever, self-actualization, hierarchy of needs. That's it. That's the self-actualization when I fail someone for cheating. I'm self-actualized. I'm doing my job. A defender of higher education and quality okay. Anyway, so like an English paper, you can't turn in one giant quotation, right? It doesn't fly. But you take other people's work and you build on it and you add original effort to make an English paper, research paper, right? So if you want to cite a source, fantastic. Use your resources. I got paid a lot of money to copy paste code, right? But this is academia. You need to cite your source and you need to add original effort. So the bulk of your work, 51%, is the bulk, right? That's the majority, 51%. I'm cool with that, is your own work. Right. Cite all your other sources. I'll show you how we can use ChatGPT and other sort of AI large language model tools to generate code for the boring stuff. But what we need to do is learn how it works and understand it and tweak it and modify it so we can read and write code. So when the chat bots fail because they can't handle super complex things, we get to step in and shine. And that's really where people shine, with complex issues and problem solving, because chatbots are not smart and not intelligent, right? They're good prose machines. They give you something that looks right based on how their large language models look. They have no idea if it works or not. And that's why you can have a conversation with the chatbot and convince it that 2 + 2 is 5. And eventually say, oh, you're right. Thanks for telling me. Like, these things are nonsense. There's a really cool article. I got to remember to share it here. Someone put together, and I hesitate to say it because I think blockchain stuff is nonsense, but it was a blockchain crypto smart contract that had a chatbot that the entire idea was you needed to convince the chatbot to give you all the money. And the reason it used all the crypto nonsense was that every time you asked it something, you had to pay money using the blockchain. So you kicked in $1 to ask it a question to try and give it you the money, the prize, and whoever broke it first won. And it had this whole system. It was really interesting. But someone finally convinced it that paying them was what it was supposed to do, even though the instructions were not to do this. They're like, oh no, paying me is just whatever it was. And AI bots working in customer service and having access to money and refunds is scary stuff, because people will do bad things with fun toys. So sort of the bane of computer science. We can come up with all sorts of cool fun features and toys and bells and whistles that are really nice and helpful. And then someone comes along and says, you know what? I can do bad things with that. And we're like, crap. Well, now we can't have nice things. So that sort of thing. But cite your work. We're fantastic. We're going to use the tools. I'll show you how to use them. If you're using something like OpenAI, you've got a link you can give me to your entire conversation. Drop the link in as your code comment. If you're using like GPT, there's no link here. I would like the entire prompt. Every question you asked it as citing your source. Hey, here's the website I used. Here's what I asked it. And even if you're paraphrasing, remember, paraphrase is rewording someone else's ideas. You cite your source for paraphrasing. It's fantastic. I'll say like paraphrasing is probably like half your work, half the bot's work. In terms of the 50-50 split here. Not exactly, but it's kind of close here, So it's sometimes hard to get it to give you help without giving you a solution. So one really cool tool that's really fun is this CIS 50 from Harvard. They've got a computer science introduction course, and they've done a version of ChatGPT that they've designed to be like a tutor, where it gives you help but not answers. So this one's really fun. You can play with it. You can log in with your GitHub account here. Or when you're using a ChatGPT tool, the first thing you tell it is, hey, pretend like you're a tutor. Don't give me answers. Help me find solutions. And then later in your conversation, it has that in its records, and it will try not to give you answers. Again, it's not perfect. It's failable, but that sort of thing can be really helpful, right? We want to use these tools smartly to help us here. And again, you're taking the class to learn Python, hopefully. I mean, I guess you have to take the class that's required. But ideally, you're going to learn Python so you can do cool stuff in data science later with Python. And if you don't know how Python works, because the bot wrote all your code, you're not going to be able to use any of the libraries here. And then you're going to have no idea what's happening in your upper level classes, and you'll fail out. And then that's really sad because you've already invested so much time, energy, and effort into it to fail your senior year. That really sucks. Don't do that. Okay, so put in the time, energy, and effort now. It's a 4-credit class, and someone decided, I actually looked this up because why else would I be up at 2:30 in the morning writing a syllabus when I could be looking up things on government websites? The federal government has a standard for every credit hour. There's a minimum of 2 hours of work outside of class that are required to call it a college credit hour. I don't know how they measure that, but the standard says minimum. I always thought it was average 2 hours, and some people were faster, some people were slower, but it's supposed to be a minimum. So I really need to up the workload, apparently, to make sure you're spending 4 hours in class. And if for the 4-credit class, 4 hours in class means 8 hours outside of class. So just this class alone is a 12-hour-a-week commitment on your schedule out of however many hours you have a week in a week, right? 12 hours for one class is a bit, right? 12 credits puts you at 36 hours a week just for school stuff, and you guys have lives, and you need to eat and work and do things. So it's a lot of work. But if you put the time, energy, and effort in, you'll get it done. Right? Anybody in 1501? Did we make sure everybody got it done? Right? I think one person failed. They just didn't turn in the final project. I'm like, you never told me you needed help. They're like, oh, I was having a hard time with it. Did you tell me or come to class? No? Okay. I don't know. I can only do so much. So I tend to think of myself not as a teacher, but someone who facilitates your learning. Because learning is a very individual sport, right? You get to learn things. I don't make you learn. I can give you information. And it's up to you to learn it. It's up to you to practice it and do those sorts of things. So 12 hours a week will get you across the finish line, almost guaranteed. I can't exactly guarantee that, but put the time, energy, and effort in. If you get stuck on something, work on it yourself. Practice your troubleshooting skills for a good half hour to an hour. Bang your head against the wall, try things, Google things, ask the chatbot things. After an hour, stop. It's not worth it. You're just going to be pissed off at the work. You're going to be pissed off at me. You're going to be pissed off at yourself and have a bad time. Just ask me. Most of the time, I can get you unstuck in 5 minutes. Right? It's a quick conversation with me to get you moving again in the right direction so that you're making progress. But learning how to troubleshoot and running into an error and trying to find solutions for it is a super important skill. Did I show you guys the shirt? The Amazon shirt, the Google the better than the average bear. Okay, I don't need to do that one then. But really, Googling solutions, finding things and trying them is what sets developers apart from everyone else. We don't just give up. Oh, I'm getting an error, I'm done. Why? What are we going to do? Can you try other things? Can you look for solutions? Can you do these sorts of things? It's a persistence and troubleshooting sort of mindset that gets you across the finish line here. All right. So cite your source. I'll show you how to do it. I'll use it in class and copy paste things and cite my source, hopefully being a good example of doing that here, because there's a lot of things that can automate or speed up that make us more efficient, which is cool. And that's what tools are supposed to do for us. They're supposed to make us more efficient so we can do other more interesting things that the tools can't do, right? There's lots of crazy people around on the internet here that we can argue with, because arguing with people, strangers on the internet, is the best pastime, right? It's the new American pastime. That think artificial intelligence is going to reach the artificial general intelligence, the AGI threshold. And most of the experts are like, no, that's a bunch of nonsense. Here's the list of open problems that have not been solved, and your large language models don't solve them. Large language models look really fancy, but they just make up crap. They don't actually know what they're doing. It's they don't think, they just make up stuff. And then you have one bot talk to another bot to check each other, and at some point the bots all agree. But there's diminishing returns on making bots talk to bots and train bots and make them better here. And no one pays enough attention to how much manpower went into training these early large language models. We paid lots of people terrible wages overseas to say, yes, this is a good solution, no, this is a bad solution, to train the models to be as good as they are. They didn't just come out of box working as good as they do. It was a huge amount of effort that went into making these things better. And things like scraping all the code on Stack Overflow, all the questions and answers on Stack Overflow to train bots how you answer questions for technical things. Well, now that we have all the chat bots, the traffic to Stack Overflow is like half of what it used to be. So there's less material to train off of. Less questions being asked, less answers being given. So there's going to be less to train on with the bots. So it'll be a really interesting future in the next couple of years to see, can we keep progressing them? Incrementally, I'm sure, yes, but I don't know if we're going to see another big leap and bound for quite a while. But we'll see. I don't have a doctorate in artificial intelligence or anything, so go talk to the really smart tenure track profs who research this sort of stuff. But none of them are saying the world is ending and we should all abandon computer science degrees because we won't need programmers anymore because the computers will code everything. No. Well, that's what they said 20 years ago when I was in school. They're like, oh, all the programming jobs are going away. No. I mean, there have been some layoffs. It's been a little weird in the industry, but things go up and down. People still program things. Yeah.
I mean, about that, I heard that like many CS grads, they're not getting, not all of them are getting jobs because, like for a couple of reasons. For example, many of them like use AI or just cheat, and when they get interviewed, they just don't know
Yep.
how to answer. And I mean, and there are so many CS graduates. I mean, everybody is going to CS.
There's a lot, but it's not overwhelming numbers. Right? If you look at how many graduate versus all college graduates, we're still a very, very small percentage of that.
I mean, how the lower level like jobs, the lower level CS jobs that are coming out, like you need to be like highly skilled in CS.
It depends on the organization. So some of the bigger organizations have gone through some resizings and they realize they don't need huge numbers of developers to do the things they're doing. And then other companies are like, oh, look, you can fire half your people and still be profitable or be more profitable. But work still happens. Every industry in the world uses software. Right? There's not a single industry in the world that doesn't use software somewhere. So work is still happening here as we organize things. Yeah, definitely. If you cheat your way through school using chatbots for everything, you won't get a job because you know nothing, and they can tell that very quickly in an interview. When we interview people, I was part of the interviewing team. You can tell real quick who knows their stuff and who doesn't.
That's a metric 100% governed by yourself too.
Yep.
You know what you're getting into. You're not gonna. You're just gonna
Yep.
teach yourself and you ChatGPT all the time.
Yeah, you're in control of it, and it's tough.
Which
So.
is also a hard thing, right? So like you see all the people around you getting hundreds on everything because they can cheat the professor, use ChatGPT. So like, where do you want to draw that line for yourself?
It is awkward in the way we measure things and give rewards for things and have letter grades for things. The incentive is to get 100% on everything, regardless of the method, because that's what you're rewarded for in school, but you're not rewarded for that in industry later on. Like, we're not perfect. We're not actually a meritocracy where the best people get the best jobs, this sort of thing. But in general, the people who know things do well. That sort of, it's not perfect. We've got issues, but if you've done well, you've learned a bunch of stuff, you've got projects you can talk about. That was really the coolest thing we talked about with people who we interviewed is what work have you done? What was interesting about it? What was hard about it? What did you learn? What did you run into? How did you troubleshoot that? And how did you work with people? Like, we had a rule that we had no brilliant jerks at the company. And that was my favorite culture rule. No brilliant jerks.
Okay.
So no one who's a brilliant coder, they're amazing, and they just were cranky all the time and yelled at people and treated people like crap. It wasn't going to happen, which was awesome. So I worked with a bunch of really nice people, really smart people. And we're excited to share. We all were a bunch of nerds. But yeah, and you can tell who can work with people and who can't when you interview them. Like if they've never talked about working in a team before, that's a big pass. Like if you don't know how to work on a team, we're not going to hire you. Even as a fresh college grad, like you've got to have some group work you can talk to. Like, okay, I understood how to delegate. I understood how to take tasks from people. I understood how to do my part or how to go ask for help. One of the hardest, biggest issues we had with people is if they don't know what they're doing and they didn't speak up. Like, oh, here's your task. We did it done in a week. And a day goes by, 2 days goes by, 3 days goes by, 4 days goes by. And they're like, oh, I'm having a hard time now. And like nothing's gotten done in 4 days. because they were banging their head against the wall for 30 hours thinking, oh, I can't ask for help. They're going to think I'm stupid. Like we know junior engineers don't know everything. That's why they're junior engineers, right? That's why we've got senior people. You go and ask for help. That's the way the system was designed. So you got to speak up. We got off on a weird tangent there. I'm sorry. It's good stuff.
It's an important tangent.
It is.
I think that's a lost metric by a lot of people in school these days, right?
Yeah. I mean, you can go watch a bunch of YouTube videos, and learn how Python. I don't know.
Yeah, that's true.
For late work, I don't take stuff late. It's for your own incentive to keep up, because generally the people who get behind on things never get caught up. And it just piles up and piles up and piles up, and then they fail. If you've got something going on, reach out to me first, right? With prior approval, yeah, I'll work with you. That's fine. But for the projects, I generally go over solutions in class. I think that generally goes well, and people think it's worthwhile and not a big waste of your time. If it is a big waste of your time, tell me. I don't have to do it. But in general, it seems to go over well. So I go over solutions in class. After that, I can't take it, right? Because there's already been a solution. So if we have to do something, we can look at other options. But I can't take it after I've posted a solution. I think that just makes sense. And then other stuff you should see in all the syllabuses. We've got a food pantry, again, that Maslow hierarchy of needs. It's really hard to do anything if you're hungry. And schools are realizing that when we get measured on how well students do, one of the things we can do is give them food. It seems really stupid to say it like that, but that helps students succeed by meeting basic needs. And it's crazy that it took people in higher ed this long to realize that, because we've known about this stuff for a long time. This is our COVID policy is still in here. And then all the university-wide policies are available in Canvas here. I should point out, because I always like to harp on this one here, I forgot earlier, the University of Michigan policy on sexual violence is awful. I don't know why, but there's specific wording in there that you have to be beyond drunk to be unable to give consent. Specifically says beyond drunk. I'm not a lawyer. I don't understand it, but that one pissed me off when I read it. That's nonsense, but sure. So just be aware. We've got a policy. The U of M lawyers are all over that. Good luck, right? We are a business with a side hustle of education, right? Sure. Yeah, that's it for the syllabus. Hooray. That was a downer note, I'm sorry. Awesome. So let me go grab the link for GitHub here. Mine, CIS 2001. So I'll drop this one in here. Again, I'm going to use this for all the class examples here. So I'll drop that in here so you have it. So anything you want to see that I did in class will be here. Of course, I thought I turned that off. Weird. Course repository. I think I used lowercase. There we go. Yeah, everything's lowercase. I have a Discord server. If you like Discord, if you don't like Discord, ignore it. Doesn't matter. But you can join, you can react to a message to get access to channels that are class-specific channels, those sorts of things. I think it's much better than other tools. It's in my pocket all the time, and I'm on other Discord servers. So if you like direct messaging, great. If not, that's fine. I've got my silly website I linked to here. It's got links to the course repository and my graphics and my little bio here and things. Sure, it's fun. I spent like 10 minutes on it one time, so now I have to keep it and link it because I spent so much time on it. And I paid someone to do this graphic because I thought it was really fun. I'm a big nerd. I'm sure you're surprised. All right, so for GitHub, right, the idea with GitHub is a distributed source control system. So if you have a copy of the repository, a clone of the repository, you have everything. So we can go out and other open source tools, like VS Code here, has a GitHub repository. This is Microsoft's repository. They own it, but it's open source, so anyone can go and view the code and build VS Code if they want to themselves or contribute to it, which is actually kind of neat. Like, there's people who contribute to this just for fun, essentially, and go fix things. Microsoft pays some people to maintain it, obviously, but it's open here. So you can go and look at, so this is the source folder for source code here, and go and see how any of this stuff works. Probably somewhere in here. Here's like the editor. Here's the browser. I don't actually know most of this stuff here. Mouse handler, TS. These are TypeScript files done in JavaScript. So that's lots of fun. Why not? You can go and see the code. Right? It's all viewable here. And then one of the cool things that Git does is it tracks things, it tracks all those commits and changes down to the line level. So when you're looking at the file, you can flip over to blame here, and you can see every commit in which every line was changed. So this line of code was changed 7 years ago by this person. If something starts breaking in my software and I track it down, there's some sort of bug here, and this file is suspect. Hey, I'm getting an error from this location, this module here. It's probably not the line that's 7 years old, right? That's just a guess here. Maybe we can go find something more recent. Again, I just picked a random file like, hey, 5 months ago, someone reverted fixing hovered appearance in chat panel. I don't know why. Maybe you can go look at it here. So the Git summary messages, that's the small box. Does someone want to grab the door? Sorry, it's a little loud. The summary message shows up here in the list of Git commits and the blame section and your history. The description box, the big box, is the bigger section down here. Right? So your summary shows up at the top, your description shows up here. I don't care what you put in there. When you go work for someone, they'll tell you what to put there. You just smile and nod and put whatever they say in those boxes. It's perfectly fine. So you can see, hey, these things changed and when they changed, which is really fun. Or you can look at the history of the file. So this one is this history here. So of this file, I can go to history and I can see a commit-based every change to this file. So it's not looking at individual lines. This is when it was changed, and you can see then all of the changes at once for this mouse event work in progress that they were working on here. So this was added, this was added, this was added, this was added, right? Green is added, green pluses are added, and red minuses are removed. So this was removed, this was added, right? So someone changed this to implement. This was just a work in progress commit. They started something that's not fully implemented yet. A little weird, but sure, whatever their process is, go for it. They wanted to get started on it here. So Git lets you see all of that stuff. So it promotes visibility and accountability on teams, which is fantastic. Like everyone can see the code you're working on, the code you're writing, the code you're changing here. There's other tools and things built in here. These pull requests are fantastic. It's part of a process. You can do code review before you make changes. You're saying, hey, I'd like to pull these changes into the main code. Someone else goes and looks at it and reviews it here. Like there's a bunch of these right now, but sure. So someone says, hey, I want to relate it to this issue here. And again, this is a GitHub thing. You can track issues in your code. Hey, closing large outline maximum call stack size exceeded. Closing a large file causes this error here. Sure, and they're telling you all these things about how it happens here. And you can see the whole history on discussions and things like that here. And then someone says, hey, I've got a fix for it here. Right? Sure. So you can have these conversations. That's one of the bells and whistles that GitHub adds as a cloud service provider of Git. Right? All these cool things you do on top of this. Other people have other tools they use for tracking here. Obviously, Microsoft wants you to use all their stuff all the time because that's how they make their money. Right? Sure. Whatever you want to do here. So you can do these other extra fun things if you've got your code out here. Other fun things we saw in 128,397 commits to VS Code since it was created. I don't even remember how long ago. Does it say? I don't even know. Sorry, it probably says somewhere. But you'll notice it's got these interesting looking orange dots or red X's or green check marks here. When we start talking about testing again and testing our code, if we have code written to test code, which feels a little silly at first, but you're going to love it, I promise. You're embracing unit testing and integration testing and having automated testing here. We can have those tests run on someone else's computer somewhere. And again, GitHub will sell you that service. Hey, why don't you use one of our virtual machines to run your tests so you don't have to do it on your laptop, which is nice. So every time someone changes the code, tests will run, and I can see, something bad happened here. Some tests started failing, and I can click on it and see, this one failed. This test had failures. And you can go look at the details here and see all sorts of, I don't actually know what any of this stuff means here, but sure. If you're familiar with it, you probably understand what it is here. Right? So we always we didn't like make fun of people or shame them or anything, but if you checked in code that failed the tests, it was a bad thing and then you had to go fix it, right? So it makes sense, right? The tests make sure the code does what we expect it to do, and it at some level doesn't do what we don't expect it to do, right? Depending on how exhaustive you want to test things here, you can go nuts testing everything, but we want to get a good amount of tests in here so we feel good about our code that we can go and update it. And depending on what our software is, the next level that you do with that, if you have continuous integration tests, where every time you integrate code, new code in, you run the tests, the next thing you can do is have continuous deployment. So I've got some buddies I used to work with who are now over at Khan Academy, and their whole process, their pipeline, if tests pass, they update khanacademy.com or .org automatically. So they can get developers writing code, getting pushed out, updating their live website multiple times a day here. Seems a little awkward at first, but the faster you can get code from conception to design to implementation and testing into someone's hands to use, generally the better it is. Right? The more delays in these things, the more issues we're likely to have. Right? With conversations being had where, oh, I wanted it to have this feature, and we just didn't do that, or whatever it happened to be. So if you can get to continuous deployment, again, it kind of depends on your software here, where things can be pushed live immediately after tests here. You can speed up your pipeline, and you can innovate faster, you can develop things faster, and ideally that gives you a competitive advantage and lets you do better work, make more money. I mean, Khan Academy, technically they're a nonprofit. They're not trying to make money. They pay their people and things, but they do some cool stuff. And their math videos are fantastic. That's the only reason I got through calculus. It took me 2 times for Calc 2, but that's okay. If you transfer credit in, you only need a C for transfer, and it doesn't affect your GPA on your Dearborn transcript. So when you apply for internships and things, and people are like, oh, you need to have a 3.0 or better GPA, you just show them your Dearborn transcript. You don't show them the community college transcript, which is a fifth the price or whatever. I didn't tell you that. I'm sorry. And it's probably too late. I'm sorry. That's the sort of thing we got to tell you earlier here. Yeah, transfer in the easy credits or the hard classes. Right? You just need C or better. No one's ever asked me for my community college transcript. I was like, here's my master's transcript. They're like, oh, good. That's nice. All right, so that's a little bit about GitHub here. So I'll put all the code out here. Again, a little different from 1501. We're just going to use one repository. If you want to make more and invite me to more, go for it. If you just want to use the same one every time, that's fine too. My little classroom.github.com links broke for some people, and I couldn't fix it. It's like a known issue, but I don't know why it didn't break for everyone. It really was confusing, but I got tired of dealing with issues. So we'll just all make your own repository, and it's good practice. So you'll make your repositories. If you ever talk to the folks who do their senior design projects, and go check them out when they do their big demo day or whatever, it's really cool stuff they do. Most of them are really cool. Some are kind of dumb, but again, it's hard to have like all really cool projects. But last time I checked, everybody was using GitHub because that's what you do. That's what you use to share code. It's a fantastic tool, and you get it for free as a student. And for open source things, you can use it for free and all sorts of other fun stuff here. But emailing code around back and forth, using a Google Drive to share code, like, sure, if you want to do it that way, go for it. But you're making more work for yourself here. And this tool is just fantastic. I don't make money, by the way, from them, I promise. Although I do own Microsoft stock, but like not enough to actually make money if one person goes and pays for GitHub. So I guess I should put that in my disclaimer. Awesome. So with GitHub, right? There's always 3 ways to do anything here. I'm a big fan of the code button for opening GitHub Desktop for cloning. Here, you can also clone it from your GitHub repository here, but I don't have it on my laptop yet. So I'm going to say open with GitHub Desktop, and I'll say open. Great, it's going to put a copy. Now, you put this anywhere you want. I don't care. Your computer doesn't care. Git doesn't care. But wherever you put it, you need to know that that's where we're going to put our projects in PyCharm, or whatever your Python environment whatever you're going to use. So it defaults to the Documents GitHub folder. Again, I moved mine out of OneDrive because Microsoft doesn't need 2 copies of my stuff because they own GitHub and OneDrive is their product. So it's my Documents GitHub folder. Great, so now I have a copy of everything that's out here in the entire history of what's out here for this repository. You can go clone VS Code if you want and try and build it and run it yourself, right? It's kind of fun sometimes, depending on how good their readmes are for like telling you what you have to do. So I've got my copy. So to make my projects then, I go to Show in Explorer, it's my favorite way, and I copy this path here, Control-C for copy, and when I go over to PyCharm, I'm going to make my project in that folder. And we'll do a new project. I'm going to drop it in that folder, right? 2001. Then mine still has the name box here, but the later versions of PyCharm don't. I don't know why they got rid of this, but And again, it's not my software. So if you have name, that will be the folder. If you don't have name, add /lab whatever, example project 0, whatever happens to be here. So mine will be week 1. And then you want the welcome script. Don't check this Git repository box. You don't want to put Git inside of Git because Git inception is just confusing. We can fix it, but it just is awkward. Then virtual environments are the good practice to do because as you install other libraries, it won't gunk up your actual Python install. Doesn't really matter. We're not going to install a bunch of weird, unsafe libraries, but it's a good habit to be in, to use virtual environments for that sort of thing. We'll say create, and it goes and makes my repository, or makes my project. Then if we put it in the right spot, GitHub will say, hey, I see a bunch of new files. If GitHub doesn't see all the new files, then you didn't put it in the right spot. It's taking a second still to make all the files. All right, sometimes you got to hit refresh. I don't know why. There, okay, now it's all main PY, and there's more files here. Sometimes it's a little dumb. All right, let me go delete that garbage, and we'll print hello world, like we all do every time, right? It's classic for some reason here. Now we should see a bunch of stuff. Come on, really? There it goes. It's okay to make more than one commit. I just knew it was going to be there. So now, again, anything in this .idea folder is a PyCharm project file, right? And you can actually read them and see what they mean here. It's not all that interesting here, but if you want to. What we really care about is the Python file. All the other stuff just makes it easier to open in PyCharm if we have it there. Right? So we'll say, hey, hello world. Again, this small box is the required box. And you can make a commit. A commit means your copy of the repository has the change. It's saved. Until we push, though, the cloud doesn't have it. It's not an automatic sync. It's not like a Google Doc that saves as you type. It's a manual. You have to sync, commit, and push to sync with the cloud. So a little bit different than some of the tools we're used to using. But as you can imagine, you probably don't want to be changing code every time you type a letter. Right? Especially if we have these tools that now, every time you make a commit, are going to go run tests. Right? So it's a little bit of a staged manual process as we go here.
You probably just want to do this at like the end of your project or
so
maybe halfway before you're done.
People have different schools of thought on that. Commits are free, and once it's in the cloud, they make their money not losing people's code. Right? Your laptop might die. Things could happen. I've had my son pour an entire pot of coffee or a cup of coffee on my laptop and fry it, which was really sad. But I had a recent commit, so I only lost like an hour of work or something like that. Not a big deal. So I don't recommend waiting to the end. Right? I say commit early and often because it's free. Technically not free. I mean, there's some electricity use for doing these things, but we pretend like that doesn't matter. And you can have a gazillion commits if you want. No one cares. It's not going to hurt anything to have a million here. So I like committing early and often. When we get to the final project, you'll have a minimum number of commits required across a span of days. For lots of reasons. One of them to incentivize you to start early. Another to incentivize you not to cheat, because it's really obvious when someone gets a solution and then puts in a tenth of it 10 times. And I see brand new code, brand new code, brand new code, brand new code, it's super obvious if you do it like that. So working through incrementally, adding features is good software practice and design practice. And so we're going to write a little bit of code, make sure it runs. It might check one of the 10 boxes. I'll write a little bit of code. Maybe I've checked off box 5 and 7 that time. Maybe I'll write a little bit of code. Oh, 5 doesn't work anymore, but 4 works. Great, sure, I'm going to commit anyway. Right? That's sort of, I want to do things incrementally, run it and test it and see if it works. Run it and test it, see if it works here. This is the best way to get stuff done because you'll know if it works here. The button here for open in PyCharm doesn't usually work. So I don't recommend this button, especially if we're doing multiple projects in the same repository. It does work if you do one project per repository. Again, we're not doing that. You can if you want. You can put one project per repository, one lab per repository. It's up to you. It's a little bit more work without the classroom.github.com link that did it all for you. Whatever you want to, float your boat. That's fine. As long as you get me the code, I'm happy. So show in Explorer, right, opens up the folder. We can see it on our computer. Show on GitHub, review on GitHub, opens up the browser. If you can't see it, you might not be logged in for your private repositories. You might say, hey, 404 not found, there's nothing here. Just make sure you're logged in to have access to it here with that. I get that one a lot as we go. But now, back in the browser, if I refresh here, we'll see, here's my week 1 folder. Again, you can see these ones. The READMEs are really nice. because then you can just paste pictures in. You can type a bunch of stuff. It's a markdown file, and PyCharm opens them really well. Like you can get a preview of what it looks like. You can do a bunch of really cool, fancy stuff in Markdown really easily. It's a pretty common format, which is great. And if you like using notebooks, like Jupyter notebooks, you can like kind of mix and match code with a Markdown. So sort of like explain what's happening in your code. There's a lot of cool examples done in notebook style like that, which is a lot of fun. It's usually a little more than we really do in class to do something that fun. But we'll look at one of their examples later. There's a cool JP Morgan Chase, or I think I showed you last semester, right? JP Morgan put out, here's their training on how to do analytics. I think theirs was like based on that with notebooks, right? All right, so let's get, again, you'll use your private repository, you'll add access to me, go to settings, add access for Eric Chinesky, no spaces, all one word. I'm the only one out there, it's really easy. And then I'll be able to view your code. If I can't see it, I'll let you know, right? Don't worry about it, don't stress over it. You can add me again if it didn't work or something like that. So I'll go check on the lab ones when those are all done. Make sure I can see all your code, make sure it's private. You don't want your lazy neighbor to copy off of you, right? After the class is done, if you want to take any of this and make it part of your portfolio that you show off, go for it. I don't care. But please keep it private while we're in class at least, just to avoid someone copying off of you and then me saying, you must have given them your work. And you're like, oh, I didn't give it to them. They stole it from me. You still, they have your work. Like, what do you want me to do? They have your work. That sort of thing. All right, so that is GitHub. Don't have too much more time for some Python basics, but chapter 1 is the refresher. If it's been a little while for Python, check out chapter 1. It takes you through all the basics here. On Thursday, we'll do a little bit of everything Python here. It'll be really boring if you had 1.501 and feel good about it. Feel free to skip. Just watch the video if you want. If it's been a little while with Python and you're new, come. We'll have a good time going through some more Python stuff. That sound good? And then Tuesday, the 14th, we'll have lab. We'll do our Unix lab. Oh, I gotta show you Unix. Shoot. If you just want to watch the video for Unix, that's fine too. I can, because you're not going to remember it from Thursday to the following Tuesday anyway. Come if you want. It's always welcome to come, but you're not going to miss a whole lot other than the Unix stuff on Thursday. I got to remember to do that. I should add that in here. Let me go change that before I forget. Add Unix. Yeah.
So I can go back and read it, but obviously showing up for labs is a big part of the grade and doing the lab assignments.
So doing the labs is a big part of the grade. Showing up for labs is on you, right?
Okay.
As long as you turn it in, I don't care. If you aren't coming to labs and then you're asking me lots of questions about the labs, at some point my patience will wear out and I'll say, please come to lab. But things happen, right? It's totally up to you. I do record the sessions unofficially. I forgot to mention that ahead of time. So as long as you're not shouting your name out, it won't end up on the recording and you all maintain your privacy.
Okay.
That's great. I don't mind my face and picture being out there. I put these on YouTube publicly because that's easier than making private videos and links and all sorts of nonsense there. So that'll be out on YouTube if you missed the lectures. It's unofficial. I did have one session where my mic was muted and there was just no audio the entire recording, and I was like, oh, I'm stupid. I really should know how to work a computer. But generally I have them available. They work out pretty well. People seem to like it. So yeah, lab is your time to practice, my time to answer questions about the lab. So ideally, yes. And they're always going to be due the week after by 11:59 p.m. What tends to happen is people then end up getting a week behind at some point, and then every time I talk about a new lab, they're working on last week's lab because it's not due till that night. And I get it, that's how due dates work. I've got things due that I wait until the due date because that's future Eric's problem. I don't recommend that for you, but go for it. Right? And
So that's why I figured it was a class lecture.
Yeah, and please don't come if you're sick. I have 7 kids at home, I have enough germs. No one wants sick people to be here, right? We got enough room, you can sit in the corner if you really want to be here sick, but don't come. Just rest up, get better, watch the recording, ask me if you have questions. Happy to help. All right, if that's it, have a great one. I will see you Thursday. Yeah.
Sir,